Hi, welcome to Operations Analytics. I'm Dr. James Rowe from Roller College of Business at Rowan University. The topic of this lecture is um, integer, goal, and nonlinear programming. Let us understand where we stand right now. We are on integer programming, which is the last chapter of Module 2. And this lecture completes Module 2 by covering integer and goal and nonlinear programming. In Module 1 and 2, we have been focusing on linear programming, and this chapter encompasses more advanced and important topics of linear programming. Linear programming pertains to predictive analytics, which is a critical discipline of operations analytics. And after covering this, we will move on to predictive analytics, which consists of time series forecasting, simulation modeling, and waiting line and queuing theory. Here are three learning objectives that we will be learning. First, understand the integer programming. Second, formulate and solve goal programming problems. Third, grasp the application of nonlinear programming problems. Agenda is that we will cover these important topics one by one in the order of integer programming, goal programming, and nonlinear programming. As an introduction, let's think about why we need to explore these integer programming and goal programming and nonlinear programming. The assumptions of the linear programming is that it is linear and it is continuous variable, and also we have only one goals. However, when we look at the real life, we find that there are more than just one goal in our business. One business might be trying to maximizing their market share and also minimizing their cost. And they are trying to also expand their advertisement. So multiple goals, competing goals they might be having. In that case, we need to think about not just one goal, but multiple goals. Also, in real life, we don't have continuous variables, such as we don't have 1.7% or 1.7.5%. We don't have such a concept. We have only whole number or natural number. And when we include natural number in our calculations, the maximum and minimum can be quite different than what we thought before. So we need to consider this integer programming in contrast to these continuous variables. Also, we have been learning about non-linearity. Linearity. However, there are also cases of non-linearity. For example, our utility or satisfaction decreases in an exponential manner, right? Sometimes it has a steep learning curve and then it plateaus. So those non-linearity exist in price or cost or satisfaction, and we need to learn how to incorporate non-linearity into this optimization. So for this reason, we need to consider these advanced topics in linear programming.